so lonely. If you're leaving, baby, let me down slowly. Let me down. Let me down.
Assalamu alaikum, once again welcome back to my channel Brain Gain. So this time on the highly request of the students, I wanna going to make this video. In this video I will try to cover a tail, vertical tail, horizontal tail, and other fuselage discussion in the assembly. If I will not be covering these topics, then the left topic will be discussed in the upcoming video. Okay, inshallah, soon. So we need, if we see about tail area, it is given sweep of the tail should be between 30 and 45 degrees. You can choose any sweep angle. Tail root chord should be 0.6. Root chord of wing tip chord is given. Half span is given. Maximum diameter is of the fuselage is given for tail. uh, Use NACA 0012 airfoil. Kit every part separately and then assemble them together using assembly design. Okay, we have the file already created, NACA 0012. You can find the link in the description. Hope so. So I will import it, and yes, here is my NACA 0012 file, GST point supply locked. Let it open. Most people make mistake while running it. When going to macros, clicking on macros and view macros, they do not select these options. Make sure you click this option of main, and from here in macros in GST point supplying from Excel, and then run. And make sure before running this you have opened the part design environment. So I'm going to start in mechanical design in part design, part one. Okay, so this is open, and now I will run it. And I need points in supplying, so I will have the option 2, and then I will enter. So this have run as same I have done for the wing. I will do it for, I will go to, I will just fit all in, then start, then mechanical design, and go to wireframe and surface design, and have the option for scaling. I will be having, for scaling I will be using element is spline. Reference point, main point, the leading point is point number 41. And the ratio we will decide from our given data. Tail root chord should be 0.6 of the root chord of the wing. Now, what is the root chord of the wing? Root chord of the wing should be 0.5 of n, and 0.5 of n means n is here 31, that is 15.5, and the root chord for the uh, tail should be 0.6 of the root chord of the wing. So I will multiply with 0.6, that is 9.3 in meters. So if I convert it in millimeters, it will be 9300. So I will just go and type 9300. Okay. Again, I will fit all in, and I will just have this scaling copy and will paste it into part body as I have done in the wing. It is not allowed to paste. So make sure that nothing is selected before while copying the scaling. Control C, part body, Control B. Now it is done. Now you can close this and hide it. Now you can little bit rotate it, and by zooming you will find that there is an open part. So we are going to join it by line. This is our point 1 and this is our point 2, and just okay, this is joined. Just fit all in, and now see that tail root chord we have used the value. Tip chord should be 0.3 of the root chord of the tail. So I'm going to have again scaling, and this one is the element. Reference is again the point 41, and we will be using the value 0.3. Actually, the because we have used the scaling one, so okay, this one is okay. Now you will see that we need to use the value of half span. So sweep, we half span should be equal to the maximum diameter of the fuselage. So what is the maximum diameter of the fuselage? Fuselage should have a maximum cross-sectional diameter of the 0.75 of the root chord of the wing. Root chord of the wing is 15.5 meters, and the maximum diameter will be 0.75. So it is 11.625. That is, in millimeters, it will be 11,625 half span. While going there and sketching, I don't know it is the exact one position to work for or not. But if I go for YZ plane, that is not looking good too. Maybe it is the ZX plane. Let's work on and then we will have the consequences and we will see that. Just make the line and make sure that your line end is just coinciding with the point number 41. So you have to select point 41 and this end point of the line and make sure it have coincidence with that, and then make sure that it is, what is the length of this? We need the length to be 11,625. Okay, this is like that. Okay, then there is the value, the tail root chord we have used, tip chord we have used, half span we have used, and for tail used nakas we have used. Let's see, tail area we don't know, and we will work on it after. Sweep of the tail should be between 30 and 30 to 45 degrees. Sweep of the tail, we'll see what is this. And the left thing is tail root chord we have used. Here we were having inconvenient my root chord should be 0.6, the root chord and sweep of 0.25 n and the geometric wing twist. So there is not geometric wing twist, but there is sweep. So for sweep, we can have, uh, let me open another file. I'm just forgetting about it. That is vertical tail and open. Okay, first I use, oh, I have made a mistake one. So I will tell you later on about that. Scaling, and then we have sketched. What was that sketch? That is this one. Okay, we can do that. No. So I will just delete this one and delete this one scaling and delete this. No, I am not going to delete this. I will use the join factor So I have joined this. Now again use the scaling. Select this one. That should be 0.3. And the reference is point number 41. Scaling option 0.3, and the point element is this one. Point is 41, and this is done to be okay. Sorry for that mistake. So fit all in. You are having this. You know that. Go to Z-Explain. Go to sketch environment and just make a simple vertical line, and make sure its length is 11,625. I hope so. Yes, it is. And make sure it's this point is in coincidence with the leading point. Okay. And now I've just again make one mistake because I've not prepared this to give you lecture, but okay, just press the Control Z. Again, press the Control Z and remove this vertical V and just tilt it something. Now it has 11,625 mm. And now make sure that this point is having coincidence with the point number 41. Coincidence. And make sure that this is having angle with this one of what given to you between uh, 0 that is 30 to 45 degrees, so you can choose in between. I'm having just 37 degrees. Okay, now you will exit the workbench and move that scaling. So I will be going to have translate feature. For this purpose, element is going to be this one. Direction is going to be okay. You can select the uh, point to point. So the start point is point number 41. Sorry, element is this one. Start point is 41 and the end point is this one. This is translated to there. Now you can hide this one. Okay, now I think we have used every value. Now you can have the multi-section surfaces. You can add these two as, and the guide one to be as this one. Okay, and make sure you have to just fill this one and do the okay. It is filled. And now if you just focus that some look like vertical tail. Now save it as vertical tail, and now if you can create the symmetry, that is this one element, and reference is maybe it is in the direction of x-axis. Yes. Okay, so this is your total is horizontal tail, and this half part, first once you make the half part, you will save it as vertical tail, and then after creating the symmetry, you will create say this part as horizontal tail. So this was today's lecture, and I will discuss the fuselage and other thing in the next lecture. So thank you for watching. May God bless you. Allah Hafiz.